Hello guys, this is Math Made Easier with Delmy. Today I have an exciting question for you. This was sent to me by a student. So we have here three straight three streets intersect in pairs, enclosing a small park. Two of the angles at which the streets intersect measure 85 degrees and 65 degrees. The length of the longest side of the park is 275 meters. Determine to the nearest end the length of the other two sides of the park. So you can pause the video and try to solve it. So from the question, we can get this sketch as we see on our screen. So from the street, from the question, say that the streets form a pair intersection. So this is each of the road here. So this one road and this another road forming a pair of intersection here. So that means that each of the junctions represent the intersection, and we have three junctions. So so that will mean that there are three points of intersection, and in plane shapes, the shape with three intersections is a triangle. So that makes the field surrounded by the street, or the field enclosed by the street, to be a triangle. All right. So the angles given to us, it says that there is 85 degrees and there is also a 65 degrees angle being given to us. So, but mind you, this is a triangle. So if one of the angle is 85 degrees and the other is 65 degrees, that means the other angle will be 30 degrees. Okay, this is because the sum of interior angles of a triangle add up to 180. So when we add all this, we get 180 degrees. Good. Now there is another hint given to us which says the longest length is 275 meters. Now the 275 meters, if being the longest length, that means that the largest angle will be projecting that length. Okay, so from the three angles that we have, the largest angle it is 85. So if the largest angle is 85, so that means the longest length will also be that means that the longest length will be projected by the 85 degrees. Okay, so from my sketch, now let me label. Let's first make the junction simple. So we label this junction here junction A, and here B, and here junction C. Now so looking at the drawing, we can say that we can just uh, um, we can say that the longest length, okay, not although it's not drawn to scale, but we can say that the longest length is the A to C, so which will be the 275 meters. Okay, now the angle which will be projecting this will be the angle opposite to that length, so which will be 85 here. So 85, that will be at B, at point B. Now the next length which is longer is the AB. Okay, based on my drawing here. So we'll have here, so that means that the point C will have the 65. That is the next angle which is larger, so 65 degrees. Now the other length will be 30 degrees. 30 degrees. Okay, so we have so we have uh, uh so we have the diagram for the question. So this can help us solve the question. So to find the other length, which is AB and BC, okay, to find the other length AB and BC, we will use the sine rule formula. You can also use the cosine rule formula, but the sine rule formula will be very fast. All right, so let's move to another page. Okay, another slide with a sketch. Okay, we try to with a sketch. So we have, sorry, A, B, C. So 65, 65, 85, and 30 to 7.5 meters. So using the cosine rule, using the sine rule, we have let's first look for the length. Let's first look for AB. So we have we have AB on sine. So the angle projecting. So we are looking for AB. So we will pick the angle projecting the AB, and that is C. Okay. Always the angle opposite the length is the angle of projection. So we have sine sine 65 degrees equals the length given to us, which is 275 sine 85. So that means that AB will be equals to sine equals to 275 on sine 85 times sine sine. Sorry, let me shift it to the side. Okay, let's shift it to the side. Okay, so we have AB AB equals 275 on sine 85 times sine 65. So pressing this on the calculator, we'll have this will give us 250.19. But remember, it says to the nearest 10. So approximately it should be 250 meters. Okay, so that is for the face. That is for the AB, 250 meters. So looking for the BC. So we do the same thing. So BC on sine the projector, the angle of projection, that will be what was it? BC. So BC, the angle of BC here, okay, with its angle of projection, which is sine 30. Okay, so sine 30. So we have sine 30 equals 275 on sine 85. So BC equals 275 on sine 85 times sine 30 degrees. So BC will be equals to, pressing this on the calculator, you also have 138.03. Then approximately it will be BC, approximately you have approximately you have 138 meters, and that is our final answer. So it so the streets will have 275 meters and 250 meters and 138 meters. So these are the two lengths, uh, two lengths that we're looking for. Okay. All right, guys. I hope you enjoyed the video. Let me know your comments. Let me know with your comments on the below, and like, share, and do not forget, if you want me to solve more questions, send the question to my email or send it through the YouTube comments section. Thank you.